Hello friends, welcome back to my YouTube channel. Today our topic is about a guide to automation body of knowledge. In this book, we learn about the automation of body knowledge. Today we discuss about control system documentation. Reasons of documentation. Documentation used to define control systems has evolved over the past half century as the technology used to generate it has evolved. Information formerly stored on a smudge hand-written index card in the maintenance shop is now more likely stored in a computer database. The purpose of that documentation, however, remains largely unchanged: to impart information efficiently and clearly to knowledge viewer. The information that is recorded involves in the conceptualization, design, construction, operation, and maintenance of a facility that produce a desired product. The documents described in this chapter form a typical set used to accomplish the goal of defining the work to be done, be it design, construction, or maintenance. The documents were developed and are commonly used for continuous process, but they work for other applications such as batch processes. The authors know of no universal standard for documentation, but these can stereotypical. Some facilities or designs won't include all the described documents, and some designs may include documents not described, but the information provided on these documents will likely found somewhere in any successful document suite. All the illustrations and much of the descriptions used in this section were published in 20, 2011 International Society of Automation ISA book Instrument and Control System documentation by Frederick A. Meyer and Clifford A. Meyer. Their book includes many more illustrations and a lot more explanation. This section uses the terms automation and control (ANC) to identify the groups or disciplines responsible for the design and maintenance of a process control system. The group and prepares and hopefully maintains these documents. Many terms are used to identify the people responsible for a process control system. The group titles differ by industry, company, and even region. In their book, the Mears use the term instrument and control (INC) to describe a guide to the automation body of knowledge. The engineers and designers who develop control system documentation for our purpose. Types of documentation. This chapter provides description and typical, albeit simple, sketches for the following documents: process flow diagram (PFDS), pipe, piping and instrument diagrams (PNIDs), loop and tag numbering, instrument lists, specification forms, logic diagrams, location plans, instrument location drawings, installation details, loop diagram, standards and regulations, operating instruction. Figure 1.1 is a timeline that illustrates a sequence for document development. They are international ship where information developed in one document is required before a succeeding document can be developed. Data is the process flow diagram drives the designs of the PNID. PNID must be essentially complete before instrument specification forms can be efficiently developed. Loop diagrams are built from most of the preceding diagram documents in the list. The time interval and percentage of total effort for each task vary by industry and by designers. The intervals can be days, weeks, or months, but the sequence will likely be similar to that shown above. The documents listed are not all developed or used slowly by a typical ARC group. However, the ARC group contribute to and uses the information contained in them. Process flow diagram (PFD). A process flow diagram is a big picture schematic representation of the major features of a process. These diagrams summarize the overall intent of the process using a graphical representation of material flow and conversion of resources into a product. Points have resources and energy are combined to produce material are identified graphically. These points are then defined in more details in associated mass balance calculations. The PFD shows how much of each resource or product a plant might make or trade. It includes descriptions and quantities of needed raw materials as well as they as by products produced. PFDS shows critical pro. Number 2. Continuous Control by Harold Wade. Introduction. Continuous control refers to a form of automatic process control in which the information from sensing elements and actu- actuating devices can have any value between minimum and maximum limits. This is the contrast to discrete control where the information normally is in one of two states such as on off, open closed, and run stop. Continuous control is organized into feedback control loops as shown in figure 2.1. In addition to control process, each control loop consists of a sensing device that measures the value of control variable, a controller that contains the control logic plus provisions for human interface, and an equating device that manipulates the rate of addition or removal of mass, energy, or some other property that can affect the control variable. The sensor, the sensor control and human machine interface HMI station and actuator are usually conducted by some form of signal communication system as described elsewhere in this book. Continuous process control is used to essentially in industries where the product is in a continuous, usually flood stream. Representative industries are petroleum refining, chemical and petrochemical, power generation, and municipal util- utilities. Continuous control can also be found in processes in which the final product is produced in batches, strips, slabs, or as web in, for example, the pharma- pharmaceutical, pulp and paper, steel and textile industries. There are also applications for continuous control in the and discrete industries, for instant temperature controller or an annealing furnace or motion control in robotics. The control device is control loop. The controller may be built as stand-alone device or may exist as shared component in digital system such as distributed control system DCS or programmable logic controller PLC. In emerging technology, the control logic may be located at either the sensing or the actuating devices.